This is a 6 video out of 10 for the tutorials that describe setting up the simplest simulation with Lumerical software. I would like to remind you that I provide PowerPoint slides supplemental to this video tutorial. This part discusses setting up a light source to excite the simulation domain. By the end of the previous video, we have already written all script lines for the source that we need for the simulation. Now we are going to create a source, and parameters designated in the script will be automatically populated in the source settings. To actually create this excitation source, we go to the section Sources in the top panel, and we choose Plane Wave. We want to excite our domain with a light source defined as a plane wave excitation. Earlier, we wrote a script for the excitation source called source1, and all those settings and variables will link to the element called source1. The automatically created source is called source, so now we need to rename this element to source1. With that, we go edit object, and we change the name here. We use this box. Okay. So once it has a correct name, the correct parameters are pulled out from the script and automatically populated into the source settings. So now the excitation source has the correct dimensions. If we look at the tab called Geometry, we can see that the software automatically populates and defines all the source dimensions and z coordinate of the source. Because our z coordinate h source is positive, now we can see that our source is on top of the computational domain. Next, we go to the tab General. We want to excite the structure with a plane wave, and we want to launch that wave along the z direction. We also want to set up the propagation in the direction which is called backward. So we do changes here. It means the wave is launched in the direction opposite to the positive axis of the z coordinate. It is the same concept and notation that we use in the CST software. Further, we go to the tab Frequency Wavelengths. In those two boxes, we define the wavelength range that we are going to use in our FDTD simulation. For our case, we need to set up from 430 to 750 nanometers. We keep other settings default, and we click OK to exit this session. As always, it's important to save project regularly. And this completes this 6th video on the numerical simulation with the Lumerical FDTD tool.